Okay, so we're looking at homework from section 4.1. This is question number 21. In the game of roulette, a player can place a $10 bet on the number 10 and have a 1 in 38 probability of winning. If the metal ball lands on 10, the player gets to keep the $10 paid to play the game, and the player is awarded an additional $350. Otherwise, the player is awarded nothing, and the casino takes the player's $10. Find the expected value, E of x, to the player for one play of the game. If x is the gain to a player in a game of chance, then E of x is usually negative. This value gives the average amount per game the player can expect to lose. In this situation, let's set up a table to organize our information. Okay, so in the top, I'm listing my gain, which are my x values, and in the bottom row, I'm putting the probability of each one of those gains. So if the player was to win and bet on the number 10 and the number 10 came up, the player's gain is $350 because that's the additional amount of money that that player receives. If the player loses, if the number 10 does not come up, then the player's gain is negative 10. So what's the probability for each one of these to happen? Well, the probability that the number 10 comes up is 1/38, which means the probability that number 10 doesn't come up is 37/38. So according to this process, the expected value is the mean of a probability distribution. We find it by doing x times the probability of x. So here we're going to do 350 times 1/38 plus negative 10 times 37/38. When we multiply these out, we get 350 over 38 minus 370 over 38, which is negative 20 over 38. So when we divide this out, we end up with negative 0.52631578994. But this is in dollars and cents, so we're going to round this to 2 decimal places. And so that's a loss of 53 cents. So the player can expect to lose 53 cents per play on average. The reason that games of chance are generally a negative expected value is because most games of chance are run by the casino, and if the game of chance didn't have a negative expected value to the player, then that would mean that over time the player would win more than the casino did. And why would the casino offer such a game? So the expected values are always negative, so that over time the casino is making money. They may lose on any individual play, but over time they'll win more than they'll lose. And that's your answer.